Okay, so now we measure angles when you actually want to measure an angle in degrees. And so, of course, you know that, for example, if I go up to here, that's 90 degrees. This would be 180. They're sort of part of our sort of life. This, which is maybe a little less part of your life, is 270. And then you make a complete circle, full circle, once around, that's 360 degrees. And so, and in fact, you hear this all the time, like when people are talking, they say, oh, I did a 180, whoop, that meant they looked right around them. Okay, fine. Well, in fact, where did that come from? Where did the measure of once around being 360 degrees, where did that come from? I mean, why 360? Why not 1,000 degrees? Or why not 100 degrees? Why did we pick 360? Well, the answer actually is pretty pathetic. It's because a long time ago, people were thinking, well, that's sort of once around is like one complete cycle. So let's just think about sort of a year, one complete cycle of a sort of a year. And so how many days? Well, they had trouble counting exactly. And so back then they said, it's about 360 days in a year to make a complete cycle. So let's just call that the measure of an angle, once around. 360. That means half of it, a straight angle, would be 180. And then this thing, a right angle, would be 90, and so forth and so on. And all of mathematics took off. But what a lame, ridiculous, foolish way of just arbitrarily giving a measure to angles. Well, it turns out that mathematicians really don't like that because it doesn't make a lot of sense. First of all, there are 365 days in a year, and then there are leap years. What happens then? Do we change the angle measures during leap years? And what do you do? So anyway, it's a big old mess. So what we try to do is think about what makes more sense and what is more useful in actually doing sort of mathematics and trying to compute things and answering questions. So to inspire this, let's think about what happens if we just sort of look at a circle that goes once around. So let's take a look at a circle that goes once around and see if we can come up with a better notion of angle measure than just degrees. So if you consider sort of going once around, let's take a circle, and for simplicity, let's suppose the circle has radius 1. Then sort of once around, we may think of as sort of like the length of this circle, just once around. Let's just take that to be the length. Now the length of a circle is sometimes called the circumference. And actually, as a formula for circumference, it's 2 pi times the radius, 2 pi r. That's the length of the boundary of a circle of radius r. So the length of this thing, sort of once around, would be 2 pi times 1, in this case, since it has radius 1. So in fact, this distance here would be 2 pi. That's the distance if I start at this point right here and go once around. That's 2 pi. Now, that sort of makes sense. I mean, that's sort of a formula that we understand, sort of independent of all this stuff. So why don't we just call once around 2 pi and create a whole new measure of angles, not degrees anymore, because that would be 360, but now a whole new measure of angles where we just think about once around being called 2 pi. Well, this new measure is actually called a measure in radians. Radians are like radius of a circle. So I'd call this angle once around, which is 360 degrees, I'd call that 2 pi radians. So now I'm defining a new way of actually measuring angles. These are called radians. So once around a complete cycle is going to be 2 pi radians. So what does that mean? It means that 360 degrees equals 2 pi, and you don't put a degree symbol, you can write radians, or rad. Sometimes it's R-A-D, rad. Well, now in fact, this allows us to do all sorts of conversions. Because if you know this fact, which is pretty easy to remember once you sort of think about how radians are made, suppose I want to convert one type of measure to the other. Well, if I divide both sides by 360, I see that 1 degree would equal, and if I divide this by 360, I would see 2 pi divided by 360, which would be pi over 180 radians. So I see 1 degree is pi over 180 radians. So if I want to convert from degrees to radians, if I had 60 degrees here, I'd have to multiply this side by 60. I multiply this side by 60, gives me 60 degrees. I multiply this by 60, I'd get radians. So in fact, this is a conversion from degrees to radians. What if I were given radians and I want to convert back to degrees? Well, you could just go back to this original fact and divide both sides by 2 pi. If you divide this by 2 pi, you would see 360 divided by 2 is 180. So you'd see 180 over pi degrees would equal 1 radian. So if someone told you I had so many radians, how many degrees is it? You just take that number and multiply it by 180 over pi, and you get how many degrees. If someone gave you degrees and they wanted to know how many radians, you just multiply the degrees by pi over 180. Now, don't memorize these two formulas because it's not worth it. All you have to remember is this thing right in here, that once around is 360, and if you think about it as a circumference of a circle of radius 1, that's just 2 pi. So just remember this, and then you can always go back and forth depending upon your needs. So let me show you with some examples. Let's make some conversions. So for example, 360 we already saw, degrees equals 2 pi radians. So we've already seen that. What about 180 degrees? Well, that's pretty straightforward because that's just half of this. So I take half of this. So that would be pi. So 180 degrees is also pi radians. What about 90 degrees? Well, we can figure that out too because that's just half of this. And so if I take half of this, I would see pi over 2. So pi over 2 radians is the exact same angle as 90 degrees, just a different type of measuring unit. Okay, now what about some more exotic ones? Like, for example, what about 30 degrees? Well, how would I do this? Well, here's exactly how I would do it, and I hope you would do it too. The first thing I say is I don't know what that is, so I go back to square one. I know that 360 degrees equals 2 pi radians. And now I have 30 degrees, so if I divide everything through by 360, that gives me the 1 degree equals pi over 180 radians. And so if I multiply everything through by 30, both sides by 30, on this side I'll see 30 degrees. And if I multiply both sides here by 30, what do I see? I see pi divided by 6 radians. So therefore, I've made the conversion. 30 degrees equals pi divided by 6 radians. You see how I did that? I just went back to the basics, divided by the 360 here, and then multiplied everything through by 30. What about 45 degrees? What's the conversion to radians there? Well, let's see. 45 degrees. I know that 1 degree equals pi over 180 radians. So if I multiply through by 45, what would I see? I would see 45 degrees, and here I'd see 45 pi divided by 180. And that can be simplified a little bit. And what would I see? I would see pi over 4. Pi over 4. If you take 45 and divide it by 180, you get a fourth. So pi over 4 is the radian way of saying 45 degrees. It's sort of like a conversion to different language. What about 270 degrees? Well, I just multiply everything here through by 270, and then what would you see on this side? 270 divided by 180 pi would be 3 pi divided by 2 radians. And in fact, that sort of makes sense, because remember, 90 degrees is pi over 2. So what's 270? It's 3 times this. So 3 times this is 3 pi over 2. Makes a lot of sense. Let's go back the other way now. Suppose I gave you radians. Like suppose I said to you, I'm thinking of an angle and it's pi over 9 radians. What measure is it in degrees? Well, now what do? Well, now I don't use this formula, but instead what I remember is that since 360 degrees equals 2 pi radians, if I divide both sides by 2 pi now, I see 180 over pi degrees equals 1 radian. So now what do? Well, now I'll multiply both sides by pi over 9 radians. I don't want 1 radian, I want pi over 9 radians. So if I put pi over 9 radians here, notice the pi's cancel, pi on the bottom, and then over 9, well, 9 cancels with the 180, and I'm just left with 20 degrees. So in fact, this is 20 degrees. How would you convert 3 pi radians? Well, you would use the exact same procedure. You'd come back here and multiply everything through by 3 pi. And if you multiply everything through by 3 pi, the pi's cancel, and I have 3 times 180 degrees. And so what's that? Well, 3 times 180 degrees is actually 360 plus 180. Plus 180, and you can add them up and see what you get. You get a 4, so you get a 540 degrees. So in fact, it's easy to convert from radians to degrees or from degrees to radians by just remembering that 360 degrees equals 2 pi radians. Now, a great question you should be thinking is, okay, fine, there's this radian thing, we can measure things in radians, but why bother? Why not just stick with the standard 360 degrees so I can say, oop, he did a 180, whoop, instead of saying, oop, he did a pi. Whoop, whoop. sort of sounds funny. Well, it turns out that using radian measure actually allows us, and it actually empowers us, to measure all sorts of important things, especially with respect to trigonometric functions. All the functions that we'll take a look at, the trigonometric functions, will be measured, the angles, in radians. We'll see why right up next. Watch the next lecture. You'll see the power of radians in action.